Hello, you are most welcome, ladies and gentlemen, to the Understanding Spirit of Anatomy on Tuesday Night Anatomy with Daniel Okwan. Today's section is going to be a revision on the epithelial tissues that we've already done. So if you've not watched that video, please visit it so that you can get more insight. I'm going to do this revision with you through some questions, help you get the correct answers, and those which are incorrect, yes, we justify why they are not correct. And so, without much ado, let's set the ball rolling. So we begin with question number 1, and question number 1 says, which of the following is false about the epithelial lining of the stomach? Now, option A says, it is of a simple type of epithelium with no goblet cells and cilia. Yeah, this is a very true statement. Yes, you get to know that the stomach is going to have a simple type of epithelium. It's going to actually be simple columnar epithelium. It's not having any, goblet cell as well as any cilia. We will see that. Option B says it closely resembles that seen in the gallbladder. Yes, the epithelial lining of the stomach, looks almost the same as that seen in the goblet cell. Only that in that of the goblet cell, that one is going to bear what we call microvilli, helping in that kind of absorption. So that one is option B, is also true. Now for C, it says the surface epithelial cells homogeneously secrete mucinous substance, which is periodic acid shift positive, just like goblet cells. Yeah, this is a very true statement. We get to know that the apical portion of the cytoplasm of the simple columnar epithelial cells of the stomach will homogeneously secrete what we call mucus, and that one will be PAS positive, just like goblet cells we've seen. Now option D says there are sparse intercellular spaces with all the cells being in contact with the basement membrane. Yeah, that's a very true statement. Because epithelial lining, yes, we get to know that epithelial cells will have little intercellular spaces. Yes, no problem. And then of course all the cells will make contact with, of course, the basement membrane because it's a simple type of epithelium. If it's stratified, then only the basal cells are going to make contact with the epithelium. So that's a very true statement. Now option E says this epithelium would be very relevant in the movement of materials. Now this is where the problem is. No, it's false, because we don't have cilia in this epithelial type, because we already said that this epithelium lacks cilia. So because it's lacking cilia, then it's not going to be relevant as far as movement of materials is concerned. So the correct answer regarding question 1 is option E. So let's try and justify that. Now it said that now this is the epithelial line of the stomach. So you get to know that now you can see these are columnar shaped nuclei. I said that if you don't see the full extent, so for instance this is a full extent of the cell, okay, it's columnar shaped, just like the nuclei being columnar shaped, okay. And we said that apical to the nuclei, yes, will be a pale staining region filled with mucinous substances, and that's why they will be PAS positive. Then we said that all these cells will rest on the basement membrane because a simple type of epithelium, in the case of stomach, simple type of epithelium. Now, but the interesting thing is that it closely resembles that we seen in the goblet cells. Just that in the goblet cells, we see what we call microvilli. So there will be microvillous processes that we find in the case of the goblet cell, helping in some kind of absorption. So that is, one thing that, we have to know. So the epithelial lining of the stomach closely looks like that we find in the goblet cells. But because the stomach epithelial lining is lacking cilia, yes, it's not going to be relevant as far as movement or transport of substances will be concerned. So one thing that we have to know is that based on the structure of epithelial lining, that one will determine the function that the epithelial tissue is going to perform. So for instance, we know that the stratified squamous keratinized or non-keratinized will be relevant as far as protection is concerned. Generally, stratified epithelium will be very relevant in protection. For excretion, yes, the kidney tubules, yes, will be very relevant. Talk about the Bowman's capsule together with the glomerulus, yes, because of the structure being simple squamous, yes, going to be relevant in excretion. But secretion in case of most glands, yes, because of the simple, cuboidal epithelium, okay, they are going to help in that kind of secretion. Also, talking about absorption. Yes, absorption in the small intestine because of some processes, some surface projections like microvilli, or talk about striated border or brush border in the case of the kidney tube, proximal convoluted tube, helping in some kind of lubrication, the things which will be secreted from these glands. Of course, talk about the goblet cells that we find in, of course, the conducting portion of the respiratory system, okay, having some kind of cleansing action, yes, by way of the cilia, helping to move, okay, that kind of particulate matter which will be trapped by, of course, the mucus. Sensory function, which of course we know that in the olfactory mucosa, okay, we are going to find the gustatory mucosa, or that kind of epithelium, which will be we are going to have the olfactory epithelium, which will be very relevant as far as sense and smell will be concerned, as far as olfaction is concerned. Of course, if you look at the ear, what we call inner ear, we are going to find what we call the vestibular apparatus. Of course, we are also going to see what we call the cochlea, which will be relevant, as far as mechanosensory function is concerned. We're going to bear what we call stereocilia. But again, if you look at what we call the epithelial lining of the tongue, it's going to bear these kind of primary papillae, which of course will have, most of them will have what we call taste buds. Yes, they will have what we call some, neuroepithelial cells, which is very important in the perception of taste. Then, of course, in reproduction, yes, mainly production of gametes by, of course, the male, germinal epithelium, complex germinal epithelium. So these are the things that, you have to know. But in the case of the stomach, it is lacking cilia. Therefore, it will not be important as far as propulsion or movement of substances is concerned. So one thing I want to indicate here is that the nature, how the epithelial lining looks like, that is how it's going to, perform the function. If it's bearing cilia, if Sawadama hair-like processes over there, then it will be very important in moving the substances. If it's lacking them, then why not? Yes, it's not going to perform that function. So we go to question number 2, and question number 2 says, which of the following is false about simple cuboidal epithelium? Simple cuboidal epithelium. We've already said that simple cuboidal epithelium will be, simple because one layer, just one single layer lying on what we call the non-cellular basement membrane. Okay, so option A says the cells demonstrate. Now there's no need for the S. The cells demonstrate centrally placed rounded basophilic nuclei. Yes, no problem, because what will happen is that although the cell looks cuboidal in shape, as wide as tall, what is happening is that the nature of the nuclei appear rounded and they are centrally placed, and those kind of the nuclei will stain with, of course, the hematoxin. For instance, if it's H&E stain that you are going through, it's going to stain with the hematoxin, therefore picking up the basic dye or the basic stain, therefore being basophilic, having basophilic nuclei. Now, option B says in the proximal convoluted tubule of the kidney, it demonstrates prominent brush border for reabsorption or absorption. Yes, that's a very true statement. We will get to know that, yes, in the proximal convoluted tubule, to ensure effective, absorption, okay, or reabsorption of the ultrafiltrate, okay, coming from, of course, the glomerular ultrafiltrate, then what will happen is that they will present with what we call, prominent brush border, which under electron microscopy, we can call it, microvilli, which will be very important in reabsorption. So that's a very true statement. Option C says it may line the initial portion of duct as seen in the lobar duct of glands. Now this is where, yes, it may line initial portion of ducts. Yes, that's a very true statement. So the initial portion of ducts, yes, we talk about what we call the intercalated duct of the intralobular duct. No, so it means that this one we are talking about lobar ducts. Lobar ducts are larger. Therefore, we expect that it's a stratified. What is stratified cuboidal or stratified columnar? So that one is, that's a wrong statement. That's a wrong statement. So already seen our answer. That's option C. But let's go on to look at the other things. Now, option D says the mesothelium of the ovary is frequently lined by this epithelial type. Yes, that's a very true statement. You'll get to know that the general mesothelium is made of simple squamous epithelium. But in case of the ovary, it is lined by what we call, simple cuboidal epithelium, so-called germinal epithelium of the ovary. But it's actually, a misnomer, so to speak, because that epithelial lining, okay, just covering the surface of the epithelium, therefore doesn't give rise to, the functional gametes of the ovary. So that one is actually a misnomer. But one thing is that, at old age, it may become simple squamous at old age. But generally, for, a reproductive each individual. Okay, then what will happen is that mesothelium of the ovary will be lined by simple cuboidal epithelium, deviating from a normal rule. Now, option E says it is seen in the thyroid follicles as well as the primary unilaminar follicles of the ovary. That's a very true statement. You get to know that. So the follicular cells of the thyroid gland as well as the follicular cells of the primary unilaminar follicle of the ovary. Yes, you are going to see that. So let's try and justify these. So there we are. Now these cells, now you can see that although the cells appear roughly cuboidal in nature, the nuclei, which is roughly centrally placed, yes, it's actually rounded. It's actually rounded, and it picks up the basic components of the stain. So it's basophilic. But in the case of proximal convoluted tubule of the kidney, you can see these things projecting into the lumen, therefore more or less like making the lumen relatively smaller, occluding the lumen. Okay, unlike in the distal convoluted tubule, which you don't see these prominent brush border, and therefore making the lumina of the distal convoluted tubule, becoming what we call, a bit wider compared to that of the proximal convoluted tubule. So that is, one thing that, I want you to know, that in the case of proximal convoluted tubule, it is actually, endowed with these prominent brush border, making the lumen relatively smaller. So it means that, yes, this epithelium will be very important as far as secretion is concerned. Then apart from secretion, mainly for reabsorption, for absorption. That is what, we are going to see. Now we said that the initial portion, now there's a secretory unit of duct, lined by these basket cells or the myoepithelial cells, okay? And then the proximal portion of the duct, or the initial portion of the duct actually, is going to be what we call the intercalated duct of the intralobular duct. Those ones are lined by, of course, simple cuboidal cells or simple cuboidal epithelium. But as you move on, yes, then there's a striated duct, assuming, yes, this one are short cuboidal or cuboidal cells. The striated cells being roughly columnar in nature, but present with basal foldings. Okay, then as you move on, get into what we call the interlobular duct, then there will be pseudostratified columnar, then to what we call stratified columnar, to lobar, then becoming stratified cuboidal in that manner. So as the ducts become larger, then they assume stratification, and therefore lobar ducts are not going to be lined by simple cuboidal, but rather intercalated duct of the interlobular duct of glands will be lined by what we call simple cuboidal epithelium. So justifying mesothelium, now we said that mesothelium generally, yes, will be a simple squamous epithelium. So you can see these cells. These are flat cells, which you are going to see in the outermost coat of most of these internal tubular, like the stomach, like the jejunum, the ileum. Yes, their outermost layer will be lined, okay, by what you call, this simple squamous epithelium, and that's what we call mesothelium. But in the case of the ovary, what will happen is that we see simple cuboidal epithelium, okay, the so-called germinal epithelium. But I've said that, yes, and here's a friend, germinal epithelium, because it's not going to give rise to the female eggs, okay? It's not going to give rise to the female ovum or the secondary oocyte at the end of the day, because these ones are going to just line it. But I said that at old age, it may, regress or shrink and assume this squamous, surface or squamous nature. So there we are. Now in the case of the thyroid gland, they form these cells. They form this kind of follicles around. These are the follicular cells, okay, surrounding this kind of colloid over here. And this also, simple cuboidal in nature. So we find it in simple cuboidal, epithelium of what we call the thyroid gland, follicular cell of thyroid gland. But I've told you that in the case where the thyroid gland is, inactive, then it may become simple squamous. But if it's hypersecretory phase, then it may assume columnar epithelium, simple columnar epithelium. Similarly, in the case of what we call the primary unilaminar follicle, we have simple cuboidal epithelium. So you can see these cells. These are some cuboidal shaped, rounded shaped nuclei, so simple cuboidal epithelium. But in the case of what we call primordial, it is squamous. So you can see these flat cells. And in the case of the primary multilaminar is having, can you see these cells? These are, all cuboidal rounded cells, rounded nuclei. Okay, so stratified. Okay, so there's one layer, another layer, but this one is just a single layer of cuboidal cells, but these are multiple layers of cuboidal cells. So that is what I want you to know. So we go to question number 3, and question number 3 says, which of the following is not true as regards pseudostratified epithelium? Now, option A says it is a simple type of epithelium since all the cells have direct contact with the basement membrane, but the false stratification is due to the fact that not all the cells reach the same apical level. Yes, that's a very true statement. Yes, although all of them, yes, by rule, for simple epithelial tissues, all of the cells will have to make contact with, of course, the basement membrane. But what is happening is that the pseudostratification, the false stratification, is a result of, yes, not all the cells reach the same apical level. Now, option B says this is associated only with columnar shaped cells and may bear cell surface modifications. That's a very true statement. Yes, we see that pseudostratified epithelium is restricted to what we call pseudostratified columnar epithelium. Yes, we can't have pseudostratified squamous or pseudostratified cuboidal. We have only pseudostratified columnar cells, and may bear cell surface modifications, which are specialization like talk about sericilia, talking about cilia. Okay, so these are some examples that we have with regard to that one. Now, option C says respiratory epithelium seen in most areas of the conducting portion of the respiratory system is pseudostratified ciliated columnar epithelium with goblet cells. Now, this is a very true statement. We'll get to know that pseudostratified ciliated columnar epithelium with goblet cells is literally, or the layman will call it respiratory epithelium. Yes, in the conduction portion. Maybe in the conduction portion of what we call the respiratory system. That is where we are going to find these kind of epithelial, this kind of epithelial lining. And of course, we know the reason. The reason is that yes, there should be cilia to trap these kind of particulate matter. There should be goblet cells to trap them, so that through this mucociliary escalating action, yes, we can propel this kind of trapped particulate matter in the mucus. Either we expectorate it or of course you swallow it so that they get digested by, of course, the hydrochloric acid in the stomach. So that's a very true statement. Option D says in the ductus epididymis and ductus deferens of the male reproductive system, it bears pterocilia. Yes, that's a very true statement. Yes, in the case now I've told you that pseudostratified columnar epithelium with pterocilia, we are going to see it in the areas. The pterocilia will be very important in absorption. In the ductus epididymis, of course, the ductus deferens, absorption of testicular fluid is very important, helping eventually in the concentration of what we call the sperm cell in the maturation as well. But of course, we said that in the inner ear, yes, you can also have that one there. That one will perform mechanosensory function. Now, option E says the PEG cells of the uterine tube bear cilia for the propulsion of ovulated secondary oocyte. Now, one thing is that yes, after ovulation in the ovary, yes, the oocyte will have to be propelled into, of course, the uterine tube, actually into the ampulla of the uterine tube for possible fertilization. Okay, by the functional sperm cell. But what is happening is that propulsion is done by what we call the tall ciliated cells in the uterine tube. Okay, we will get to the uterine tube. Will have two types of cells, and then the predominance will be based on whether we have a lot of estrogen or we have a lot of progesterone. For instance, more ciliated cells will be seen in the case of estrogen dominance. Okay, so for instance, during the follicular phase of the menstrual cycle, yes, more ciliated cells. Then of course, during the uterine phase, where of course progesterone will be released, more, then what will happen is that we will have more of these secretory cells are what we call PEG cells. Okay, so the PEG cells are not responsible for the propulsion. Okay, it's rather the tall ciliated cells. The PEG cells are unciliated and therefore will not be relevant in what we call propulsion. We already established that cilia will be very important as far as movement, is concerned. So it means that the correct answer is option E. But one thing that you should know is that out of all these, and now the question says which of them is not true about stratified epithelium. Remember, in the case of what we call the uterine tube, is not pseudostratified, but it's actually simple columnar epithelium having ciliated and non-ciliated cells. Only that the ciliated cells are tall columnar, with the non-ciliated cells being short. So let's justify that. So there we are. Now we said that if we talk about pseudostratified columnar cells, what will happen is that all the cells, so this is the epithelial lining, all the cells will make contact with the basement membrane, but not all the cells are able to reach the same apical level. Okay, so that is what we see. So different levels, so assuming that kind of false stratification. Okay, not all the cells reach the same apical level, but all the cells make contact with, of course, the basement membrane. Now specifically in the case of what we call, and they may bear these kind of things that we call, cell surface modifications. So these ones like cilia, like these ones we have stereocilia. So cell surface modifications can be seen with pseudostratified columnar epithelium. Okay, but one thing is that yes, frequently we tend to see that these kind of cells will be associated with this kind of what do you call it, unicellular gland that we find over here, which we call it the goblet cell. Now this goblet cell, yes, will secrete what we call mucus, okay, or mucinous substance, which will of course combine with water to form mucus. Now what is happening is that in the case of the conduction portion of the respiratory system, this kind of architecture that we see, which we have pseudostratified columnar epithelium, which are ciliated, okay, bearing what we call goblet cells, we call it respiratory epithelium, and that will be very important as far as trapping particulate matter and propelling them, taking them out of the respiratory tract will be very concerned. Okay, so that is what we see over here. I said that in the case of the ductus epididymis as well as ductus deferens for absorption of testicular fluid, it's very important that, of course, they bear what we call stereocilia. I said that stereocilia is actually a misnomer. It should have been stereomicrovilli, because it's actually a subtype of what we call microvilli, because relevant in absorption but not movement of materials. So that is, one thing that you have to know. Now, in the case of the uterine tube, so please concentrate over here, not the side. In the case of the uterine tube, you tend to see these cells. Now, we have these cells which are tall columnar cells. Now, these tall columnar cells bear actually cilia, but the short cells over here, okay, bear what you call microvilli. They bear microvilli. So those ones are what we call the peg cells. These cells are the peg cells. They are non-ciliated. It is these tall columnar cells which are ciliated, which will be very important in the proportion of the ovulated secondary oocyte of the ovum, okay, for possible fertilization in the ampullary region of the uterine tube. So please get to know that. So we go to question number 4, and question number 4 says, which of the following is not true about the olfactory epithelium? Now, option A says it is of a pseudostratified epithelium and bears microvilli. Yes, that's a very true statement. It's bearing pseudostratified epithelium. Only that, yes, it is bearing what we call microvilli. Yes, it may have cilia, but importantly is that it's going to bear what we call microvilli. Now, option B says it is associated with simple tubular gland known as Bowman's gland. Yes, you get to know that the olfactory epithelium, yes, downward growth of it will give us a gland which is actually a simple tubular type of epithelium, and that one is called Bowman's gland or olfactory gland. We get to know that. Option C said it shows keratinization and seen in the smell detecting areas of the nasal cavity. That is, what is happening is that yes, it doesn't show keratinization, but because keratinization is restricted to only stratified squamous epithelium. Only stratified squamous epithelium, which we find it in the epidermis of skin. Yes, that is what we're going to see. Okay, so but in fact, it's going to find itself in areas where it will be relevant for smelling. Okay, smell detecting areas. That one is true. So this option, because of the keratinization, makes this question, this becomes the correct answer. Now, option D says its main cell types are basal cells, supporting cells, and of course, olfactory cells. Yes, of course, basal cells will be more or less like the germ cells, or the, let me say, the germinative cells, so to speak, so that they can give rise to, of course, they are not specialized, so they always give rise to either the supporting cells, which of course supporting cells can also be called sustentacular cells. Sustentacular cells like sustaining, something sustaining, that means it's supporting it. Okay, I don't know about sustaining, kind of, that kind of thing. And then of course, olfactory cells, which will be very important for the smell, for the detection of the smell proper. Those ones are going to be those ones which will bear the microvilli. Okay, which will bear the microvilli. But one thing is that these olfactory cells can also be called neuroepithelial cells. Neuroepithelial cells. Now, option E says its damage may lead to anosmia. Yes, that's a very true statement. Yes, if there's damage to it, okay, or let me say there is that kind of some viruses, secreting some product to line this area, just like in the case of the COVID-19, yes, then it may lead to what we call anosmia, whereby you may not be able to smell. So even if there's any smell, you can't detect it. So that's what we call anti-smell. Now we call it anosmia. So that is what we see. So it means that all these things are going to be true about it, except option C. Let's justify it. So there's the olfactory epithelium. That is also pseudostratified columnar epithelium. Okay, now because we've said that yes, if it's stratified epithelium, we don't see cell surface processes or cell surface modifications. These cell surface modifications that you see are actually what we call microvilli. Okay, so these, although you see different layers of cells, it is not supposed to be a stratified epithelium. All the cells make contact with the basement membrane, but not all of them are able to reach the same apical surface. Although this is the artistic viewpoint, one thing that you have to know, it is, pseudostratified columnar epithelium bearing these kind of microvillous processes. And it is frequently associated with this gland, where it's a simple tubular. You can see that that's a single duct with that secretory unit, simple tubular gland. And that's what we can see over here. That is what we call Bowman's gland or the olfactory gland. Very important in detection of smell. Then we said that there will be 3 cell types which should be associated over here, and these 3 cell types, these are the neuroepithelial cells. Okay, the neuroepithelial cells, and those neuroepithelial cells will bear what we call the microvillous processes. Apart from that, it will bear what we call these sustentacular cells, which are columnar shaped. The sustentacular cells will also be there. Then apart from that, we also have what we call the basal cells, which are horizontally oriented at the basal region. The basal cell. Let me show you another image to show that. So there we are. This one is a bit better. Now, although yes, it is an olfactory epithelium, therefore we don't really need cilia. Yes, frequently we tend to see cilia over there. But one thing is that yes, we have the stem cells, which are the basal cells at the horizontal placed basal region. Okay, then we also have the supporting cells, okay, which are also known as the sustentacular or the sustaining cells. They're frequently associated with these Bowman cells, which are simple tubular glands. Then apart from that, we also have what we call the these cells, which are very important in the detection of smell, which are going to bear the microvilli. We call them these cells what we call olfactory cells or the neuroepithelial cells. So this one, if there's damage, say if there's injury over here, and your baby trainer say if there's injury, what is happening is that then he can't smell. Okay, so anytime you can't smell, anytime I ain't say adibiana can be, then it means that there is an injury to this epithelial lining, especially to, of course, the neuroepithelial cells, the olfactory epithelium. All right, so we go to question number 5, and question number 5 says which of the following is incorrect about stratified squamous epithelium? Stratified squamous epithelium. Option A says it is only the superficial cells that demonstrate the flatness. Yeah, that's a very true statement. Although the word squamous means flat, stratified, it means multi-layered, it means otatado, and flat, not otatado. But what is happening is that it is not the fact that yes, although they are stratified, it is only the superficial cells. I'll show you that it is only the superficial cells which show the flatness, but not the basal cells. The basal cells may show columnar to cuboidal to polyhedral cells, but eventually the most apical cells or the most superficial cells will show the flatness. Option B says the epithelium frequently demonstrates epithelial pecs. That's a very true statement. One characteristic feature of stratified squamous epithelium, whether keratinized or non-keratinized, is the presence of these epithelial cells. We will see that. I'll show you that. Now, option C says the non-keratinized variety lines wet surfaces of the body that are subject to high degree of abrasion. Yes, that's a very true statement. You get to know in the vagina, wet area, like your mouth, talk about your anal canal. Then what is going to happen is that yes, because these areas are subject to high degree of abrasion, of course, and they are wet surfaces, they will be lined by the non-keratinized variety. Okay, if there's dry areas, like the skin, they will be lined by what we call, the keratinized form, because that area there's more protection needed. Now, option D says the keratinized form is seen associated with both thin and thick skin. Yeah, that's a very true statement. The only difference with thick and thin skin is the fact that thin skin will have 4 layers, excluding stratum lucidum. But in the case of thick skin, it's going to have 5 layers. Now, option E says it is a classical example of an epithelioid tissue and thus protective. Now, this is the wrong statement, and therefore this becomes the correct answer, option E. Now, the fact that yes, it's protective, no problem, because stratified. Anytime the epithelial line is stratified, and especially when it is flat, then it means that yes, it's going to be very important in protection. But one thing is that it is not an epithelial tissue because it's going to have a free apical portion. If we are not having, we said epithelial tissues will show polarity. If we are not having a free apical portion, then what will happen is that it becomes what we call epithelioid. Like the medullary region of the adrenal gland that we've seen. So please visit that video, you get more instance regarding these kind of epithelial tissue. We give a mnemonic like seal, okay, to support that. The sebaceous glands, the epithelial cells of the thymus, and what have you. Please get to know that Leydig cells, thicker cells, and what have you. The Langerhans cells and what have you. So please get to do that video and watch it. So justifying these answers, yes, lining wet areas of the body will be stratified. So you can see several layers of cells. You can see that the most basal cells, they appear like columnar cells. Some of them are polyhedral, yes, some being cuboidal, but at the end of the day, as you are reaching the apical surface, they appear flat. So you can see the nuclei appear flat. Okay, they are they are wider than long. Okay, so they are wider than long. So that is stratified. So areas in the body where they are subject to high degree of aberration, maybe able to make prayer, for instance, if there's a show not for yes, in the esophagus. Okay, talk about your anal canal. Okay, talk about your vagina. Okay, these areas, yes, they are subject to high degree of aberration, but they are wet surfaces. Okay, they are always dry. They be unharmful. So those areas are going to be the areas which will be lined by what we call stratified squamous non-keratinized epithelium. So please get to know that. And because there's keratinized epithelium, it is only the basal cells which will make contact with the basement membrane. The apical cells don't have anything to do with the basement membrane. And we said that this one is an epithelial tissue, not epithelioid, because it's going to have what you call a free apical portion. Okay, just like this one is going to have a free apical portion. There's nothing sitting on top of it, a free apical portion. But frequently, let me demonstrate something that's frequently they are associated with distance. Okay, so when with the epithelium, okay, stratified squamous epithelium, what you see about them is that they dip into where, now we said that beneath every epithelium, after them epithelium be epithelium, epi means above. Epi means above. So on top of something we call connective tissue, you have epithelium. And one thing about epithelium is that you can see the cells are tightly packed. And whether H&E stain or any other stain, you tend to see that the epithelial cells tend to pick up the stain quite intensely than what you call the underlying connective tissue. And the underlying connective tissue will have large interstellar spaces. Okay, but the cells of the epithelium, they are closely packed, but connective tissue, the mpapimba cells, they are separated. Okay, that's what you see. But the bone there, epithelium, so basal region, or move into the connective tissue. It moves into the connective tissue. So because it's moving into the connective tissue, it gives this kind of ridge-like appearance that we call them epithelial pecs. The man in every epithelial pecs, and they are exclusive to what we call stratified squamous epithelium, whether it is non-keratinized or the keratinized form. So you can see that this is the keratinized form, the epithelial pecs that you see. Okay, in the same way, the connective tissue which is beneath them will also move into them. So it's a give and take. So as the epithelial tissues will be moving into the connective tissue likewise will be moving into the epithelial tissues. Okay, these things are what you call connective tissue papillae. Okay, we see that where we start with the organology themselves. Okay, so please, you can go and watch. If you still want to understand some of these things better, you can watch the systems histology that I've done. So you get to the playlist and get them. Now, we said that epithelial tissues, if they are stratified, is for protection. If they are flat, it's actually going to even confer more protection because the cells will be tightly packed to aid in that. But when they are even become keratinized, okay, so there's a non-cellular layer of keratin. There are no cells over there. The cells have lost their nuclei. There are no cells over here. That one is very important in protection. Okay, very important in protection. And we are going to see this in the case of the skin. Stratified squamous keratinized epithelium. Okay, so please get to know that. Dry areas. Now let's go to question number 6. And question number 6 says, which of the following is not accurate about transitional epithelium? Now option A says it is frequently referred to as urothelium and it is stratified. Yes, that's a very true statement, because they line the intrarenal and of course extrarenal passages mainly. Yeah, it's going to be called uro has to do with urine, either quadrants or urine, urothelium. So anything which has to do with the passages through which of course the urine has to flow through, whether within the kidney or outside the kidney, yes, they are going to be lined mainly by this kind of epithelial line, which we call transitional epithelium. Now option B says it is specifically referred to as such due to its varying presentation of the epithelium between the stretched and the relaxed state of the organs it lines. That's a very true statement. You got to know that sometimes it's stretched, sometimes you see the squamous, you may see some cuboidal cells, we see that, okay, but classically we see something, okay, about them. Now option C says this epithelium is impermeable to salts and water and may have fusiform vesicles. We will see that because they are stratified epithelium. Yes, what is happening is that the most apical cells is what we are going to use in justifying them. So one thing that we get to know is that yes, sometimes if it gets stretched, what will happen is that the most apical cells appear squamous. You may also see some cuboidal cells. You may see some some cells which are binucleate and all that. We will see that, and they are frequently actually going to be seen. Some we see the fusiform vesicles. Once you see fusiform vesicles, then we know that we are looking at what we call transitional epithelium. And one important feature about them is that they are impermeable to salt and water, because I said that is where urine is going to pass. And so they don't need to reabsorb them. So this epithelial lining is not supposed to reabsorb salt and water in the urine. Okay, so they are impermeable. Option D says in the relaxed state, it classically has umbrella-shaped cells superficially with pear-shaped cells in the intermediate layer. Yeah, that's a very true statement. You get to see that, yes, mainly we expect that the cells should be umbrella-shaped. Okay, they should be dome-shaped cells over there. But what is happening is that when they stretch, okay, this is a relaxed state. When they stretch, they may even assume squamous shape, with the intermediate cells bearing that kind of pear shape. I'll show you that. Now, option E says it can be found in the kidney calyces, okay, major and minor calyces, renal pelvis, ureter, urinary bladder, and the entire urethra. Yeah, that's where the issue comes in. No, not the entire urethra. All the areas that we've mentioned are true areas that we're going to find transitional epithelium. Yes, again, you'll find it in the urethra, but actually the proximal aspect of the urethra, in the case of males, actually the prostatic urethra, not the entire urethra. For instance, the membranous urethra may be lined by pseudostratified columna, to stratified columna, then to the penile urethra, yes, all the way becoming what we call stratified squamous non-keratinized epithelium. So that is what we get to see, not the entire urethra. So that's the wrong answer. That's option E. Let's justify that. So that there we are. This is the epithelial lining. This is the transitional epithelium. So you can see transitional epithelium is actually stratified. It's multi-layered, having several layers of cells. Okay, but what we see is that you can see that these cells appear flat. The most apical cells over here, they appear flat. Okay, these ones are more or less like cuboidal, or let me say dome-shaped cells. But I'll show you something. So this is what we call transitional epithelium. Transitional epithelium, impermeable to salt and water, and the ability to stretch is very important. It stretches so that, for instance, in the urinary bladder, okay, or stretch, okay, so its ability to stretch and being impermeable to water is very important. Otherwise, urinary bladder, then we are going to reabsorb most of them. No, they are not very relevant as far as they will not be permeable to salt and water. So there we are. Now one other thing too is that they show this kind of binucleate frequently. You see that the apical cells, some of them may show two nuclei over there. They tend to show this kind of syncytial appearance, having this kind of two nuclei over there, binucleate cells. Then one thing is that the most apical cells, they are actually dome shaped, they are umbrella shaped. With the intermediate cells, usually the intermediate cells, they show this kind of pear-shaped appearance. This one not very classical, but you can see one over here. They show this kind of pear-shaped appearance. And then frequently, now something like this, you might think that this is stratified squamous non-keratinized epithelium, which people frequently, confuse with it. But what you should know is that you can see these kind of whitish appearance, whitish structures in the epithelium. These things are what you call the fusiform vesicles. Okay, so we don't see fusiform vesicles in stratified squamous, whether keratinized or non-keratinized epithelium. Again, you don't see these epithelial pegs that we saw, and then the connective tissue papillae. So making this one classically, transitional epithelium. One thing I've told you is that stratified squamous non-keratinized epithelium frequently resembles this, but you can use some of these features to distinguish between them. We said that we are going to be fine in what we call the major calyx, renal pelvis, ureter, urinary bladder, and proximal aspect of the urethra, not the entire urethra. So let's go to question number 7. And question number 7 says, which of the following is false? At the gastroesophageal junction, there is a transition in epithelium from stratified squamous non-keratinized to simple columnar without goblet cells. Now, that's a very true statement. We know that in the esophagus, we are going to have stratified squamous non-keratinized epithelium because it's a wet area where it's subject to abrasion, very close to the external environment. Now, that's a principle. If we are getting closer to the external environment, then you need more protection. Okay? For instance, when your esophagus, your anal canal, your vagina, talk about your urethra. Okay, these areas, because they are getting closer to the external environment, then they should be lined by what we call stratified squamous epithelium. Okay, but these are wet areas, therefore it should be what? Non-keratinized. But then, if we are going to the stomach, because it's secretory, yes, mainly simple columnar epithelium, but it is lacking goblet cells. And I told you that homogeneously, the epithelial lining of the stomach will be secreting what you call mucus. Please get to know that. So that, yes, it protects the wall of the stomach from autodigestion from the hydrochloric acid that is secreted by the parietal cells. Now, option B says the simple squamous epithelium of lymphatic and blood vessels is known as endothelium, but not mesothelium. I've told you that if in the case of these, organs which are, covered by serous membrane, okay, or which are intraperitoneal, for instance, these ones will have mesothelium. But this time around, we are looking at the endothelium, okay, the simple squamous epithelium of lymphatic vessels as well as blood vessels. That one is called endothelium. You see that. Option C says at the anorectal junction or the rectoanal junction, there's a transition in the epithelium from simple columnar epithelium with goblet cells to stratified squamous non-keratinized. That's a very true statement. We get to know that, yes, moving away, yes, entirely, the small and large intestine, including the rectum, will have simple columnar epithelium having goblet cells. But as you get in closer to the external environment, once again, we need stratified squamous non-keratinized wet area. Okay, now option D says the high regeneration ability of epithelial tissues is consistent with its high vascularity. Yes, characteristically, we know that epithelial tissues show high regeneration ability. There's high mitotic ability. Only that, yes, they don't have high vascularity. They are avascular, actually. They are avascular. They don't have blood vessels. And through diffusion, okay, from what we call the underlying connective tissue via the basement membrane, that is where they are going to get their nourishment from. So please get to know that. So it doesn't, this is a wrong statement. That's the correct answer here, option D. Now for E, it says the epithelial lining of both small and large intestines is simple columnar epithelium with goblet cells. I've already established that. So that's a very true statement. Justifying that this is the epithelial lining of what we call the esophagus, terminal aspect of the esophagus, okay, showing this kind of galloping appearance over here. And that is what, the epithelium dipping into the connective tissue moving into epithelium, epithelial pegs and connective tissue papillae, stratified squamous non-keratinized. Because it is going to line wet surface and the esophagus, okay, is going to be non-keratinized. Very protective. But secretion is needed in the stomach, therefore it is lined by simple columnar. So if you take a very close look at it, it is the nuclei appear columnar shape. Simple columnar, as we've already seen simple columnar epithelium, okay, without goblet cells, also without cilia. Please get to know that. Okay, so that junction transiting over there, we will change epithelium from stratified squamous non-keratinized to simple columnar epithelium without cilia, without goblet cells. Now, in the case of the rectoanal junction or the anorectal junction, yes, from the, we said that the large intestine, including the rectum, so there's a rectum having simple columnar epithelium, but we can see these kind of white cells in there, and that represent what we call the goblet cell. Numerous goblet cells are there. So simple columnar epithelium. Okay, 2 what we call stratified squamous. So you can see this, although you can't see the most apical cell shape, but what's happening, you can see the epithelial pecs and the connective papillae, making it stratified squamous, non-keratinized epithelium, wet surface. Okay, that's the transitional point, anorectal junction. Then we said that a simple columnar, you can see, simple squamous epithelium, okay, the tunica intima or blood vessels, the first layer, just very close to the lumen, will have simple squamous epithelium. Okay, that is what we call endothelium and not mesothelium. So please get to know that. You find it also in lymphatic vessels, not only in blood vessels, but also in lymphatic vessels. Now again, both small and large intestines, okay, will be lined by simple columnar epithelium. You can see the cells are columnar shaped, simple columnar epithelium, but having these goblet cells. These whiter cells we find over here are goblet cells. Remember, the whiter cells that we saw in transitional epithelium, okay, were actually fusiform vesicles. Transitional epithelium are stratified. Simple columnar epithelium are not stratified. Having these things we call goblet cells, secreting mucus. Now, one thing is that, yes, let's review, the characteristics of these kind of epithelial tissues. Because one thing is that, yes, they are avascular. That's the key thing I want to tell you. They are avascular. They are resting on a basement membrane. No problem. I will show you the basement membrane, because it's through that basement membrane that underlying this kind of epithelium, being the connective tissue, through diffusion, that epithelium will get the nourishment. Okay, and the cells are tightly packed, as we said, tightly packed. Okay, cells are tightly packed with little or no intercellular spaces between them. They show high regeneration ability, and that one doesn't reflect the high vasculature. It's not avascular actually. Okay, so please get to know that. So that is that one. And then we said that, yes, they will frequently make use of these junctional complexes, the cell junctions, talking about the desmosomes, hemidesmosomes, talking about the gap junctions, talking about the tight junctions. So please visit that video to get more insight. Okay, so please, that is that one. Characteristically, it is lacking blood vessels. So one thing is that we said that beneath every epithelium there should be a connective tissue. But separating the connective tissue and the epithelium, okay, and for that matter, epithelium sitting on what we call this structure is what we call the basement membrane. Basement membrane. Basement membrane is contributed by both epithelial cells as well as, of course, the connective tissue cells. Basement membrane is made up of what we call the reticular lamina, and actually the reticular lamina is what we call the more apical portion. Although, yes, we expect that this portion should be the apical portion, but actually this reticular lamina is the more apical portion, which is secreted by the force the connective tissue components, actually the loose connective tissue areola. Then we also have what we call the basal lamina. The basal lamina is actually the basal component. So this is the apical component, or the upper component. This is the lower component. That's the basal lamina. But actually, the basal lamina is secreted by the epithelial cells. And then the basal lamina, okay, is actually under electron microscopy. We see two layers: a clear layer, which you call it lamina lucida, and a much thicker layer, which deeply stained, is what we call the lamina densa. Remember, the basal, the basement membrane is non-cellular. There's no cell over there. Get to know that there is no cell over there. And basal, the basement membrane, the collagen type that you're going to find over here will be collagen type 4, but sometimes you may see collagen type 6 and or type 7 as well over there. So please get to know that. So there we are. I said that, yes, so there's the epithelium, okay, secreting what we call the basal lamina, and then there's a connective tissue component beneath it secreting what we call the reticular lamina, forming the basement membrane. So that we said that this is the connective tissue which is vascular, which are having these blood vessels, so that through nourishment, through diffusion across the basement membrane, some nourishment will get to what we call the epithelial cells to nourish them. Okay, please get to know that. So we go to our last question. Okay, question number 8, and question number 8 says, which of the following is false about epithelial tissues? Option A says epithelial tissues may arise from all the 3 germ layers of the embryo. That's a very true statement, from both ectoderm, mesoderm, endoderm. Option B says complex stratified epithelium is the germinal epithelium proper of the seminiferous tubules of the testes. That's a very true statement. You will get to know that. Complex stratified epithelium, that's the germinal epithelium that we find in what we call the seminiferous tubule of the testes. But actually, yes, I am calling it proper to qualify it. Yes, because in the case of the ovary which lines the surface, yes, it's actually not, really a proper germinal epithelium, because it doesn't give rise to the functional, gamete of the female. Option C says epithelial tissues may line body surfaces as well as form glands which are specialized for secretion. So glands are specialized for secretion. So epithelial cells are doing two things: either they line or cover surfaces, either external surfaces or inner surfaces, as well as their orifices. Then what they are doing also is that they may grow downwards and then form what we call glands, which are important in secretion. Now option D says in true stratified epithelia, it is only the most basal cells that make contact with the basement membrane. Yes, I don't need to overemphasize it. That's a very true statement. We'll get to see that. Option E says generally stratified epithelia are protective. Yes, we have several functions that the epithelial tissue is going to perform, like secretion, like protection, propulsion, movement of substances, like absorption and what have you, diffusion, like filtration, okay, among others. But importantly, what is happening is that if it's stratified, then generally it will be protective in function. So justifying that developmental wise, yes, epithelial tissues are coming from all the three germ layers: ectoderm, mesoderm, endoderm. Unlike in the case of nerve tissue, which will come from only ectoderm. In case of muscle and connective tissue, coming from only mesoderm. Okay, for epithelial tissue, it's coming from all the three germ layers. Now, this is a cross section through the testes, and this one we are showing you the functional, aspects of the testes, being the seminiferous tubule, that's a factory for sperm production. But what we see is that these things that they are, we are going to have what you call the epithelial line over here on magnified this way. We are going to see two cell types. We are going to see cells which are stratified, okay, so line on top of the other. These cells form what we call the spermatogenic series of cells, and they are stratified, okay. But what will happen is that there are other cells. These ones are going to give rise to the functional gametes of what we call the male, the spermatozoa, these stratified cells, okay. So the more mature ones are placed more apical, so getting closer to the lumen, closer to the what we call the adluminal compartment or the luminal compartment. But in the basal compartment, they are the most immature cells, the spermatogonia, okay. That's what we see. But one thing that we find is that there are other cells which are not going to give rise to what we call the functional gamete, okay, giving some support, okay. And those cells are the subtentacular cells, the supporting cells, or the Sertoli cells. So those Sertoli cells are not stratified. Please get to know that. And they form this kind of tight junction over here to form the Sertoli junctional complex, form what we call the blood barrier, the testis blood barrier, or the blood testis barrier, okay. So very important in that. So that is why we call it what we call stratified, okay, complex stratified, germinal epithelium, okay, complex stratified germinal epithelium. But these ones are not going to give rise to what we call the functional gamete. Please get to know that. So we said that yes, epithelial tissues are doing two things: either they line surfaces of the body, or locally sometimes they will proliferate, grow downwards towards the connective tissue area, and then they will form glands. So the distal portion of the gland will be the excretory unit, and then the proximal portion, being the duct, will convey the product onto the surface epithelium. If you have certain, that's exocrine gland. In case of endocrine gland, that local proliferation, yes, will give rise to a distal portion, being of course the gland. But what happens is that the connecting link, the connecting stalk, obliterates, okay, degenerates, and for that matter, yes, you may have these kind of cords or these kind of follicles, okay. And that's why the endocrine glands will be endowed with a lot of blood vessels, because they don't have a duct to convey their product, so that through diffusion they will send their products into the bloodstream to affect a target organ. So please get to know that. So epithelial tissues are doing two things: they cover or they form glands which are specialized for secretion. So for instance, endocrine glands will be very important in secreting hormones. Yes, these exocrine glands may be important in secreting certain things, like talk about enzyme-rich secretions, like saliva and what have you, okay, pancreatic secretions and what have you. Now, finally, what we want to see is that we said that epithelial tissues, if they are stratified, okay, if they are simple, yes, all of them will make contact with the non-layer basement membrane, simple, a single layer. But if they are multi-layered and they are stratified, it is only the most basal cells which make contact with, of course, the basement membrane. Okay, and we know these classifications already. Columnar shaped cells will have columnar cells, okay, which are taller, than wide. Okay, having columnar shaped nuclei which are very closer to, of course, the basal aspect of the cell. Cuboidal shaped cells, yes, will have, cube shaped or roughly having the same, being as wide as tall, having rounded nuclei which are roughly centrally placed. Then if the cells are flat or they are wider than tall, okay, yes, they are squamous. Okay, so please get to know that. So that's the true stratification. But if it's false stratification or pseudostratified, then of course all the cells will make contact with basement membrane, but not all of them will be able to reach the most apical portion of the cell membrane. Okay, so please get to know that. All right, so I hope you find this revision exercise helpful. I'm very grateful for your time this evening. Madam Asibebri. Please, if you've not subscribed it, make sure you subscribe so that we start the many other important aspects of the anatomy also able to say. Have a good night and may God richly bless you.